Hi, today we are going to talk about disjoint implementation. So what is disjoint set? So disjoint set is a data structure, and that data structure is being constructed using union find. That data structure could be either it could be an array or that could be a map. And what we achieve from that, actually, we come to know once that data structure is being constructed using union find, we come to know, we can ask the question that if one node, suppose U, is connected with V, so that data structure can tell us that if they are connected or not. So we can come across this query and that data structure can answer it quickly. So that's the whole disjoint set. And now if we talk about implementation, at the very start it is given us the number of nodes. Suppose we have 7 number of nodes. Each one are individually represented here. I'm not talking about right now with the edges. So individually they are right now independent, autonomous, they're not connected. We will construct an array, which is normally called root array. In this root array, the indices represent these nodes. Let's put 0 for 0 index, 1 for 1 index. And for the sake of map, in case, let's suppose their name is like A. So we can say A is connected with A's parent is B, and B's parent is C. So that will be in case when we have a map. But in array, we were just saying the indices like exact nodes. And here, we were going to show their representative. What is that? I will talk about this. All right, so what is representative mean? That from disjoint set, the main idea is that we are going to make some set. And in each set, we have one representative. Suppose we have set A, we have set B. In set B, another representative is there. In set C, we have another representative. And set mean that there could be number of nodes could be here in that also. And there is only one representative of that. So when we are saying connect B and C, just union them. So once we connect them, so in that case, either C or B have to say, we will choose this one as our representative. So that's the whole idea about disjoint set. Now here, initially when we have number of nodes, we initialize our array, empty array, and then when we never talk about edges, so every node is a parent of itself. So they are representative of themselves. So 0 is representative of 0, 1, 2, 3, 4, 5, and 6. Now when we say we have to connect 0 and 1, we are going to union them. So union is going to say connect 0 and 1. But it will say to 0 that who is your representative. So 0 say my representative is 0. And then it will ask the same question, who is the representative of 1? So 1 say I am the representative of myself. So here in this array you can see these two questions was being asked first from union, and 0 say my representative is myself, 1 say I am representative of myself. So once we found the representative of themselves, how we will find, we will talk about later. So once we find that, we just union them. So union is going to do two tasks. First, it is going to connect. Second part, it is going to choose a common representative. So we will going to connect 0 and 1 first, and here we are going to select 1, say I choose 0 as my representative. So I will just change it here, and I will say 0 is the representative of 1 now. Now we talk about the second one, our second edge, 0 and 2. So when we connect 0 and 2, 2 say my representative is 0. So we will just change it here, 0. Now when we talk about next edge, which is 1 and 5, so when we connect 1 and 5, the second thing that who is the representative between 1 and 5. Suppose 5 says 1 is my representative. So at this particle index, we have to just mention 1 is the representative of 5. So we just connect all of them. 4 and 3, we connect them at the first step. And 3 says, let's suppose 4 is my representative. In that case, we have to just change it here. Now, the question how we come to know that this is the representative. In a very simple answer is our root node or our representative node, how we can come to know that this is. So that's a very simple thing, that index should be equal to the value. When we have index which is equal to the value, we will come to know that this is the root node, and that's a representative node. So here in this case, you can see 0 says, which is the index, and the value was same. So it present representative. So this is actually the duty of find function. So find function is going to find the representative. So find function look for representative by just looking the same thing, that if index is equal to the value, in that case we will say this particle index or value is representative. So here now when we have connected all the edges, connect 2 and 4 when we entertain this edge. Now we have now two sets separately. This one is one set and that's another one. They're disjoint set. Now when we are going to say connect 2 and 4, so for 2 we will find that who is the representative in the first step. So we will come to index 2. We'll find the value 0. So of course 0 is not equal to 2. What we'll do, we'll go to 0 index and then we will see what's the value. It says my value is 0. Oh, index is equal to the value. So we find the representative of 2. Now we will say here that 2's representative is 0. Now we will ask the same question from 4. Who is the representative of 4? So for 4 says I am representative of myself. So we will say, okay, we found another representative. They are not connected. Now in that step, union is going to connect them. So when he is going to connect, in that case, either of these set, either this one or that one, have to change their representative. So suppose 4 says, okay, this set says we choose the representative from here, and what it will be. So 4 and 3, in that case, 4 says my representative is 2 now. So 4 will just change its representative to 2. And that's the whole implementation of this disjoint set. So pretty simple. Union is going to do two things. Union takes 2 vertices and then it first asks the question about the representative of U and representative of. So once we find that, you can just consider representative as a root, or you can call them find function, because the find's job is to find the representative of the particle vertex. We will say find U and find V. We will get the representative of both. Suppose they return X, it returned Y. Now we will look here that if X is equal to Y, both representative of same, so it means they're connected. If they're not, we will connect them in the next step. Here we are going to connect by updating our array. And that's the whole idea and implementation. And for find, I already told it is just going to look if index is equal to the value. So once it find that, it will say I found the representative, and that's all. Hopefully that makes sense. In the next video, we'll talk more about what is quick union and quick find. See you in the next video. Bye.